Alright, so this video will focus on Chapter 5, Section 3. And the first thing I want to do is I want to go through and solve all of these equations. So if I want to solve for y, of course, you have to do the multiplicative inverse of 6 over 1, which would be 1/6 to both sides. Or you might just divide by 6. In either case, you'll get 15 as your answer. What I'd like you to do is pause the video and then try to solve the rest of these. Alright, so now that you've had ample time to do that, let's check to see how you did. So x is -6, x is -16, y equals 19, x equals -4, and then finally y equals 7. So today we're going to do a different method. So far we have graphed, we have solved by substitution, and today we're going to work on solving by elimination. So let's go through these. Very first thing that we're going to do is go through and we're going to write these two things down. So I'll have 2x plus y equals 2. And our second one will be x, I'm going to write it down here, x plus 5y equals 1. And what I want to do is I want to somehow create an equation here in which I could delete or subtract one of these variables. So check this out. If I actually take this entire side and I multiply it by -5, so let's just rewrite this, so times -5, so I'm going to do this side by -5 and this by -5. I'm going to have something else. I'll have -10x minus 5y equals -10. Now I'm going to go through, I'm going to actually add these up. So -10 plus 1 is -9x. My y variable is gone because this equals 0. And then this equals over here -9. So then I'm going to divide by -9. And I'll have x equals 1. Well, if x equals 1, I could then go in here and plug this in and figure out what the other value should equal. And it's up to you how you want to solve it or which one you want to put it into, but I'm going to put it into this one here. So I'm going to rewrite this and I'll say now 1 plus 5y equals 1. I'm going to draw my line, subtract 1 here, subtract 1 here, and I'll have 5y equals 0. I'm going to divide both sides by 5. And in this case, y equals 0. So my ordered pair that works is 1 and 0. And let's see if that's true. So if I plug in a 1 here, 2 times 1 is 2, plus 0 is 2. If I plug in a 1 here, I'm going to have 1 plus 5 times 0 is 0, so 1 plus 0 is 1. So this is the ordered pair that works for both of them. We're now going to go in and solve these systems by adding or subtracting the equations. Now these are actually set up to make it a little bit easier for you. If I look at number 2, well, number 1 first of all, I have my x and then this y will get rid of it, right? Because I have a positive y and a negative y, and I just add. And so then when I figure it out, I'll have 8.5 and 1.5. For this one, the x's will cancel out, and I'll have 4y equals 28. And then I'll have to divide 28 by 4, and you'll get like 7. And if I plug this back in, 14, so x plus 14 equals 8. We'll have to subtract 14, and I get -6 for my x value. This one here is not clear cut right now, so I'm going to go through here, and I have to first of all just rewrite these. So I have 2x minus 3y equals 14. And I'm going to have 2x plus 4y equals 21. Now I'm going to want to make it so I get rid of something. So I can multiply this entire side by something as easy as -1. And this whole side by -1. And when I do that, I'm going to get -2x minus 4y equals -21. And now this x goes away. I'm going to have -7y equals -7. I'm going to divide. I'm going to get x equals 1. I'm sorry, y equals 1. And I can plug that back into either one of these. So let's plug it into this top one here. So I'll have 2x, and I'll have -3 times -1 equals 14. This becomes 2x plus 3 equals 14. I'm going to subtract 3 from both sides. I'll have 2x equals 11. So in this case, x equals 5.5. So my ordered pair is 5.5 and 1. Must have done something incorrectly. Let's double check this. So I have positive 3, negative, and I just located my error. So I said y equals 1, not negative 1. So there's my error. And if I do that, I will have a negative 3. And then this would become a positive 3 to both sides, which would be 17, right? And then x divided by 7, or 17 divided by 2 is 8.5, which is how I get this value, 8.5. So I was going to erase this and not show you that I made an error, but in the same sense, I think it's okay. It's a teachable moment. I made a mistake. I was able to look at my work and figure out where my mistake was, and I figured out that it was the 8.5 and the 1. And then finally, the last one is 1 and negative 8. So here's a key idea. First of all, you have to multiply one or both equations so that at least one pair has the opposite coefficient. Step 2, add or subtract the equation to eliminate one of the variables like I did here, right? And then you solve for the resulting equation for the remaining variable, and then substitute the value that you have, like this y, into a variable, and then solve it to get your other term. So here is another one for you. So what I'd like you to do is I want you to try to solve this. So pause the video and try to do this. All right, so the first thing is this makes it pretty easy because this gets rid of it right away, right? So I have 2x equals 14. So I have 2x equals 14. You want to solve for x, so I do the dividing by both sides, and I have x equals 7. Now that I have x equals 7, I can plug that back into one of these. So like I'll have 7 plus 3y. I have to subtract 7 here, so I'll have negative 9. So 3y equals negative 9. And then I have to divide by 3 on both sides, and I'll have y equals negative 3. So now I have my x is 7, y is negative 3, and my ordered pair is 7, negative 3. Try doing the same thing with this one. Again, the y variable cancels out. I have 6x equals 30, so x equals 5. If x equals 5, that would be 10 minus 1. So this would be 5, 1. You can do the rest for these here and solve them. This one's not quite as easy. If you look here, I mean, it's not hard, but it's just there's more steps. So I'm going to have negative 6x plus 5y equals 25. And I'm going to write the other one over here. And I'm going to make this negative 2x minus 4y equals 14. So what I want to do, sorry, that's kind of messy, but what I want to do is I want to get rid of one of these things. So I'm going to multiply by negative 3. Because if I multiply by negative 3 on both sides, that's just a mess. This would become 6x. And then negative 3 times negative 4 is negative or positive 12y. And then this is 14 times negative 3, right? So negative 42. I'm going to go through it. This gets rid of this. I'm going to have 17y equals, and then 42 minus 25. So I have 17, and it's negative. So y equals negative 1. I could then just plug this y into one of these variables and solve for it. Okay. Let's see if it works here. So here we go. So I get this right here. So y equals negative 1. I plug this back in. And I get y, or x equals negative 5. So my ordered pair is negative 5, negative 1. So then try going through and solving this one. So pause the video. So in this case, you could either multiply this by negative 2, and get negative 6x, or I can multiply by negative 3 and get rid of the y's. It's up to you how you do it. In any case, you'll get 3, 2. This one I'm going to multiply everything by 4. So I get rid of this 4x. And then this one here, I'm going to multiply everything by, well, this is a little trickier because I have it set up for like y equals. So I could actually plug this in here. This would be a better substitution problem, right? I could plug in 5 times negative 2x plus 3 equals 15 minus 5x. And I can absolutely do it. To solve by elimination, I actually have to go through and set them both equal here. So I'd want to multiply, like in this case, both sides by negative 5. But I would really recommend in this case, this last one, this is a good example where you'd want to substitute. All right, so let's do this one here. So it says you buy 8 hostas and 15 flowers for $193. Your friend buys 3 hostas and 12 daylilies for $117. Write and solve a system of linear equations to find the cost for each. Okay, so first of all, I got to think about what the equation is. So I have 8x plus 15y equals 193, and the other one is 3x plus 12y equals 117. In this case, it's a little bit trickier, right? I have to figure out what I want to multiply both things by. You could multiply both. So like in this case, I'm going to change them both into, like I'll multiply this top thing by 3, and I'll multiply this bottom one by 8. And when I do that, I'll have this 24x plus 45y equals 579, and this one here. So I want to have one of these being a negative. So you could figure out which one you want to have here. So basically what they're doing is they're switching this all to negative. And I have negative 51y. This is going to be a negative 357. And then I divide negative 357 by negative 51. And I get y equals 7. So that equals for the y value. And then I can always plug in for the x if I want to. But it's asking for the cost of this, so that's all I had to do. And that really is the